Now this is a what General Electric calls a frame 5 gas turbine. It's about 14,000 kilowatt, and it works like this. To start it up, it uses a starting motor or turbine to rotate the shaft. The shaft of the turbine is here. This part is a compressor, and these 2 stages is a turbine, all on one shaft. And out the end comes the coupling where you put your generator or compressor or whatever you want to drive. The gas turbine, once it's up to speed, the air comes in through this inlet hood. Normally there would be a silencer up here. The air goes in and turns and goes past stationary and rotating blades of the compressor. The pressure goes from atmospheric and goes up to about 8 atmospheres. Keeps on going here. Reverse flows around the combustion chamber. The combustion chambers, there's 10 of them around. The fuel is fed into a fuel nozzle, and the fire is here. The combustion chamber is cooled by the air that's on the outside, and the inside gets heated up, and the temperature at this point here is about, on today's machines, about 2,000 or even up to 2,300 degrees. Goes through these stages, stage 1 and stage 2. It cools it down and takes the energy out that goes into the shaft and goes out here through the exhaust casing, through this diffuser, and then on out. And here would be also a silencer to reduce the noise for the surroundings. The whole thing of this size machine is built on a big I-beam that is about 8 feet wide, and on top of that, in here is a lube oil tanks and coolers, and here pumps that put the lubrication for the bearings, and you can put the bearing here and the bearing there. Here are valves that take that fuel flow and regulate it to the pressure that the machine needs. It needs quite low pressure once you're fired to begin with, and then you need to control that flow so you get the right temperatures, because otherwise you'll burn up the hot parts in here. So there's a control panel that tells the fuel system valves what to do. Once it has started running and gotten up to speed, then there's a governor. The governor sits here on this shaft and knows, here's the center of the shaft, it sits here and knows what the speed is and knows what speed you want and adjusts the fuel flow accordingly. Once you're up to speed and get the generator, if that's what it is, synchronized, get it online, then you put more and more fuel. Now you cannot change the speed anymore, but you can put more and more fuel in, and the torque increases, and the generator over here would generate more and more kilowatts. And to not exceed the designed temperatures in these hot parts, in here, as you can see with these, are temperature detectors that go to the control panel and then in turn cuts the fuel down to the amount that is correct for the maximum for the machine. That's the basic way the machine works. When the machine has been brought up by the starting means to about 20% speed, then it's ready to fire. And it's fired by spark plugs on a couple of combustion chambers. And in between each combustion chamber, these 10 chambers, is a cross-fire tube. And so when a chamber with a spark plug in sees it, the pressure rises and the flame goes through the crossfire tube to the next one over, and it propagates all around. In addition to the ignition, the igniter here, spark plug, there's a flame detector. And as soon as a flame detector sees the flame, it says, cut back, because we do not want to have the amount of fuel that was needed for firing to continue. We would like to go in for reasons of avoiding heat shock. You want to cut it down to about half, and you leave it there, what we call warm-up. The spark plugs are out of the picture because they are pressure ejected out of the way. But the flame detector keeps on sensing what's going on, and it's always tricky to make sure that we don't cut the fuel back too far. If we cut back too far, the flame will go out, and the flame detector is then a protection that says, hey, shut down again. So normally that does not happen, but if it does, we must shut down. Otherwise we put fuel in and no fire, and pretty soon you have an explosion. So these flame detectors are a very important part of the starting cycle. So after a warm-up for a couple of minutes, then the control panel says, hey, start putting more fuel in. And in the meantime, with a little more fuel, the starting means still trying to get it up, and now the turbine helps start the machine. So between the two of them, it brings it on up to about 70% speed, and at that point, the clutch here between the starting means and the compressor shaft, that uncouples, and the starting means shuts down, and the turbine accelerates up to the full speed point. And then the control system takes over and governs the speed from that point on.